Okay, welcome everyone. My name is Nicholas Manousis. I'm the president of the Horological Society of New York, and it's my pleasure to welcome you here to our June 2018 meeting. As usual, we'll get started with a couple announcements. I met a few new members earlier tonight. If there are any other new members who would like to pick up your lapel pin, please see me or Ed in the back of the room or Rhonda or Ryan, who can all get you your lapel pin. And as always, we thank all of our new members for joining the society, and we thank all of our existing members for their continuing support of the society and what we're doing here. Now, you may have seen at the front desk tonight, we are selling our limited edition 2018 ties, which I'm wearing tonight, in two colors. This green, which is great for summer, and we've also got a nice blue tie there as well. If you didn't get a chance to pick one up before the meeting, we'll also be selling them afterwards. The ties are $85 for members and $100 for non-members. And as usual, all of that money gets reinvested right back into our educational programs here at the Horological Society. So pick up a tie while you can, because once these ties are sold out, they're sold out, and maybe we'll do something different next year. So our traveling education courses are continuing ahead full steam. We are going to be visiting Orange County, June 9th and 10th, and Philadelphia, June 23rd. And I'm sorry to say, I added the Orange County classes, but I've just realized that they're completely sold out. So unfortunately, there are no seats left for Orange County. If you have any of your friends in Orange County, we'll come back soon. But there are tickets available for the Philadelphia classes. So if you have any friends in Philly, let them know. It's going to be a lot of fun. It's always fun to go down to Philly and get some cheesesteaks. I was just talking with Ryan beforehand. He's already planning out his adventure in Philly. Okay, so tonight's lecture. A few months ago, I was in Switzerland on a business trip, and I had the chance to visit the International Museum of Horology in La Chaux-de-Fonds. And has anybody been there before? Anybody else? A couple. Oh, Eddie. Yeah, Eddie's been there. It's a fascinating museum. It's a huge, comprehensive museum. But there was one exhibit that really stood out to me, that piqued my interest. It was an exhibit on clepsydra, or water clocks, and it explained how they worked. I'm not going to get into how they worked right now, because I think we'll be talking about that later tonight. But what this exhibit made me think about was that there are aspects of horology which we don't really consider today too often, right? I mean, every month we talk about mechanical horology here. It's what we know and we love, and we talk about it pretty much every month here at the Horological Society. But there are other aspects. There's atomic horology with atomic clocks. We can think about horology from the heavens, from outer space, astronomical horology with sundials. And last but not least, there's fluidic horology. And tonight, we're very lucky to have the modern masters of fluidic horology here as our guests in New York. So without further ado, please join me in welcoming, all the way from Neuchâtel, Switzerland, the CEO of HYT Watches and Preciflex, Grégory Dourde.
Thank you. Thank you, Nicolas. It's a very pleasure to be there tonight in the Horological Society of New York. we are very, I say we as a team at HYT, we are very pleased to have been invited and honored to be invited here in New York. The Horological Society of New York is a very exemplary place for education. And I would say that I would love to have that kind of audience and place in order to educate in Switzerland, also some fluid time and fluid horology. Education at HYT is a central strategical point. You know, when you invent new devices, you invent also the vocabulary which goes together. And selling a HYT watch in the world can be very easy because there are some people that love the technology that reads everything on the internet. But it can be also very difficult because we have to train, we have to educate, we have to explain to the people how do what all the work that and the research and development that we have done in order to give birth to this extraordinary project. And tonight we will go through historical aspects of the fluid time, which takes place 4,000 years ago, and all the challenges that we had to carry out in order to give birth to this project and to have a new perception and the new vision of the fluidic indication of the time, like the passage of the time thanks to the liquids. New York, America, is also a key and strategic place for HYT. It's not a flattery, it's essential. You will see and you will discover that part of the key and strategic components that are inside the HYT watch, apart from the mechanical movement that constitute the fluidic device, are coming from America, East Coast and West Coast. So we love both coasts. And you know, to have the Swiss label, you have to have a certain amount of added value, which is from Switzerland. And there are lots of people that want to have 100% coming from Switzerland. And I would say that it would have been a very pity for HYT because the project that we had wouldn't have been possible without the aerospace industry, the NASA, and some medical devices some medical companies that are here, where some technology comes and does not exist in Switzerland. So I think that in the days and nowadays, there are lots of boundaries, you know, that you want to close everywhere in the world. It's important to also take inspiration from outside and not only to do the mechanical horology, but also to take this inspiration and technologies in order to bring to life a unique project. Liquids and time is a very long story. It brings us to 4,000 years ago. Heraclitus is a Greek philosopher, 500 years before Common Era. He said he was the philosopher of the change. And this change for him was the essence of the universe. And he has a citation where he says that no man ever steps twice in the same river. That means that there has been, from a very long period, an analogy between a flow of a river, a flow of a liquid, and the flow of a time. You cannot stop a river to flow. You cannot stop the flow of the time. And this analogy was really used over very long centuries in order to give some incarnation to the time. Not an abstract time, but a time which is represented, and you can visualize it. At HYT, the project that we have is to bring to life and to propose a new representation of the flow of the time. This flow of the time is changing like a river, like the time that never stands still, and this combination of liquid and time is the base and the essence of HYT project. This is a HYT watch, and you see on it the green liquid, which represents the past, your history. And the green liquid is flowing inside the tube of glass, which is a capillary. And the transparent liquid, which is here, it shows you your future. So it projects you into a vision of your day, where you are in the day, where you are in the flow of the time using the liquids. The separation of the two liquids that do not mix is the now. This is the present, and this is the indication of the hours. This is inside HYT, so lots of you will recognize a lot of mechanical horology. We have a combination of a mechanical movement, and the mechanical movement is here to regulate the time, and the second aim of the mechanical movement is also to bring the energy to the liquids to move. So we have a mechanical movement that gives the time and that moves the liquids very precisely. And the fluidic device is a device that I will explain you later, that is here in order to show the time and the passage of time. So HYT is a combination of two words that are not opposite, that we marry them together in 2012, mechanical and fluidic device. The story of the measurement of time and liquids dates approximately 4,000 years ago. In China, there's no clear evidence. There are some texts that say, okay, Chinese people invented in 4,000 before Common Era some water clocks, but there are no clear evidence. The oldest description that we have found are dates from 1600 by an Egyptian court official, which is named Amenemhet. And then we have also found the oldest water clock in the tomb of the pharaoh Amenhotep I. It was in 1500 before the Common Era. And here you see on the clay tablets that has been found in Mesopotamia, Babylon, that water clocks were an aid to astronomical calculations. So all this evidence propose this fluidic measure of the time as one of the oldest instruments to measure the time. For sure, there was the solar and the sun clocks, but the problem with the sun clock is that during the night or when it's cloudy, you cannot read the time. And there has been a lot of invention that I will show in the coming slides. So water clock uses a flow of water to measure the time. It obeys to Torricelli's law if the viscosity is neglected. And the liquids were used here to measure. And in Persia, for example, the water clocks are called fenjan. And it's a small bowl that you see here that has a very small hole here. And when you put the bowl in the water, the liquid flows inside. And when the water completely, when the bowl is completely full of water, then there is one time segment that is calculated. And it was used in order to measure the quantity of water that was allowed to the different peasants for irrigation. So it was really key. And they counted the number of bowls every X minutes or X hours that were full, and it was a measure of the time in order to allow this irrigation. Then there has two types of water clocks, the outflow and inflows. The inflows is like the one that you saw before. You have the liquid thanks to a small hole that fills entirely a cup, and you have here some marks, some indication that you see here that measure the time. So it was a very first measurement of time, and it's always the same time necessary for the liquid, for the water to go up. And you also have the outflow, like this one. This one has been found in Karnak, in Egyptia, and the principle is the contrary. You fill it with water, and it's like your bath tube. Try the experience tonight at home. You fill your bath tube and you take out the plug. You will realize, until you take an iPhone, no, a chronograph, and you will realize that it will always be the same time for the water to go out. This is the same principle. If you have a very small hole, it will take long. If you have a big hole, it will go quickly. So you can adjust the timekeeping. You can adjust the measurement of time thanks to this size of holes. Here on the Karnak, it was quite advanced because there were 12 columnas that were engraved inside, corresponding to the 12 months. And you know that with the solstice, months, the duration of the day is changing during all the year. So one columna here was used for 1 month. And the highest level inscription here was the months of the summer, where you have the duration of the day which is the longest. And you had these possibilities to measure the time and to measure the duration of the day differently between the different months, invented by the Egyptians. Here in Greece, you have the clepsydra. So clepsydra in Greek means water thief. And the principle was, it's an outflow water clock. And the aim of this instrument were to allocate period of time to the court and to the speakers in court. And they filled it completely when there was a serious case, like somebody who killed somebody else, and they did it not a big amount of water for more simple case. There has been a lot of improvement of these clepsydras with multi-tank clepsydra in order to allow a constant level of water and then a constant debit, because otherwise you have the debit that changes when you have less water, because the columna and the weight of the water is less when you are at the end. So they have transformed that in order to improve the accuracy of the instrument. Then there has been the first complications. I named it complications. I was discussing with Nicolas what is a complication. So I named it a complication here. You know Plato? Plato, the very famous Greek philosopher, was also a very genius guy. And he invented, he was really, how to say in good English, sorry for my vocabulary, he was pissed off. I don't know how to say in good, in proper is it? With some students that couldn't wake up in the morning. And he has invented the first water clock alarm. And the principle is here. And there was a siphon vessel, and with, you see here, thin opening. And when there was a sudden flow of water flowing into this vessel, then there was the air that was projected out, and the air that was projected out came here, and it's whistled like a kettle. And then it was the first alarm clock, and it worked very well, and he had really good results, as we know. Then there has been the first incorporation of gears, and also, you see here, a dial indicator. by Ctesibius. It was the most advanced clepsydra that has been invented. And you see here the first combination, for the first time, combination between gears, mechanism, and liquids. And there has been a slight transformation between the very first clepsydras, where the water used to measure the time or a duration. And here, an advanced and more precise technologies where the liquid is transforming years and decades after decades into more a source of power, but not a measure. The measure was done more and more mechanically because it was more precise, but the water was the source of the energy. And the most advanced water clocks that incorporated the highest levels of perfection were done by Persian and Chinese people. They were incorporated water and mechanics, and one very famous is done by Al-Jazari. It was approximately in the year 1200 of Common Era. And this is the Castle Rock, and it has multifunction, display of zodiac, solar, lunar orbits. And you had also the possibility to reprogram the length of the day, as we saw also with the Karnak clepsydra. And there has been one that has been offered to Charlemagne by Harun al-Rashid, and also in China, Susong, who does a 10-meter water clock. This to show that there has been a very long history of this time measurement that prepared all the period that went and that followed that I call the mechanical enlightenment period, where there has been a big revolution with the mechanics, and mechanics, thanks to very key innovations that I'm sure you have heard a lot in the precedent lectures, did a very important revolution in the history of the horology and the time measurement. And the watches, the possibility to have it also on the wrist and attain very, very high level of precision that was never available before with the liquid time. And it was the end of, I would say, the fluid horology, the fluidic time and the use of the fluids as a measure or as a source of power. But as of today, liquids have always fascinated the people. And you know that you are done, I am also, I assure you, done out of approximately 80% of liquid. And on Earth, the Earth is 75 or 80% of liquids. And when we send the Curiosity on Mars, is looking for liquids, water. When we scan to go to find an exoplanet, maybe someday we will travel somewhere else, you need liquids. You know, you can stop to eat for 20 days. If you stop to drink, after 3 days you're dead. So liquid is life. And this philosophy has liquids as the origin of the time measurement, origin of the life, was the origin also of the HYT project. What we wanted to do, we are not melancholia. It's not, we want to come back to ancient times, but we want to take the best of the two universes, and especially in terms of indication, to have to use this intuitive relation between the passage of time and the flow of the liquid. So this is the aim of this contemporary project, which is at the crossroad of science and arts. Maybe you saw and you read, it was 1 month ago, or yeah, it was really soon. There has been an article, you know, there has been a lot of people that saw that thought, ooh, God, what's happening here? In the UK, they decided to remove analog clocks from exam halls because teenagers, they cannot read the time anymore with hands. So you can say, well, they are completely stupid, we are intelligent, we will have to force them. I take it seriously, and I think that we have to think to maybe alternative way and to propose at least something different. And beside that, I have put here this Apple display. You know, this is the activity tracker face, which is one of the most popular face of the Apple Watch. And what you see here, you know, it's a flow of pixels, digits, so it's not really hot, it's not really in life. But this indication doesn't need any training. And they did that, and this is the most famous indicator that Apple just released. Now you have that on the computers also. And if you look at here, we have added Saul in the system because it's three-dimensional, it's high-tech, you see the flow of the liquid inside. But the principle of using this flow, I think, is we are at the very beginning of many instruments. You can take also a Ferrari, the latest dashboard of Ferrari. They do not have hands anymore. They have these gauges which are moving. And the times that we live now, we live transformations. And we will propose you now, and we will go into some more details in our proposal. So you see here that we do not exclude mechanics and liquid. This is the wedding. This is where we incorporate the mechanical movement and the fluidic device. And we want to take the best of the two worlds here in this proposal. So the movement is here to move the liquid precisely, and the liquids to give you this indication of the flow of the time. Here, you see the essence of the time. You see, like a river, it's a river that flows in here. You have the time, minutes after minutes, hours after hours, that flows entirely into this capillary. The day starts at 6 in the morning here, and it stops at 6 in the afternoon here. And during all the day, you have this flow of the time inside the capillary. Here is a video where you will see, this is the fluidic device. I will explain you how it works. You have here a bellow which is full of the green liquid, and here a bellow which is full of the transparent liquid. The movement, the aim of the movement is to compress this one, and by compressing this one, you will see the flow of the green liquid going forward like that. And when the green liquid is going forward, it pushes the transparent liquid into this reservoir, which is free. So you see during all the day, and you see here the compression, and here the extension, and here the liquid, which is flowing inside the tube of glass. Okay. So how to read the time on a HYT? You see that we have added here some indication of the hours. So you see that the indication here is 10 hours, and you see that the green liquid is just a little after the 10. So you expect to be a little more than 10. Then you have an indication of the hours here, like a regulator. It's 8 minutes, 50 seconds. And here you have the power reserve. So you see that you start the day at 6, noon, and when it comes here to 6 p.m., the green liquid cannot go any further. So we have a mechanism and a movement that we call the rewind, where the green liquid will come back in 1 minute to this position. And then you start the second part of the day, which is 6 p.m., midnight, 6 a.m., and then a rewind in 1 minute. When you have the rewind, the mechanical movement is still working. So you do not lose 2 minutes per day. Otherwise, we'll be in some troubles. So you will see here in this video, the rewind. Okay, so you saw that the hands were just after the 6. And you see the green liquid, this is real time, that is flowing inside, backwards, rewind into this position in 1 minute. I will explain you how do we manage 1 minute. It could have been 2 or 30 seconds. 1 minute is something that we calculated, and we did thanks to a small component. If you remember the bath tube, it's a component where we manage very precisely a hole where the liquid has to flow, and we control the speed thanks to this restrictor. So this is the fluidic device. I will dive into some explanation in order to show you all the science and the technology that we had to develop, especially for this project. This is our secret weapon, as you call it, and it required more than 15 years of research and development. And all the technology and the principle that I will show you tonight, that I will explain you, are mostly coming from aerospace, medical device, and semiconductor industry. So that's why it's a merge, and the HYT project, it's a merge, and we have merged team of watchmakers and also scientists coming from everywhere in the world, the best specialists in their domain. So the fluidic system has some particularities and some challenges that we had to tackle and to carry out. The first one is a very sharp display. Then we have to control the position of the liquid very precisely inside the watch. And then, for sure, we have to manage how the liquids are moving inside. And this is how do we control this flow on a very precise way. So let's start first with the display. As you know, the fluidic device is first of all a visual indicator. It has very high requirement in the aesthetical pleasing, intense color, then the high visibility, and the very precise shaping. So in order to color the liquids, we do produce all the liquids in-house, you know, and the two liquids are transparent. So we have to find a dye in order to integrate the dye in one of the liquid. And when we put the dye in one of the liquid, this specific dye cannot move in the other liquids. Otherwise, you wouldn't have, you know, the sharp separation between the two. So the chemistry behind that is very advanced, and we use the best specialists in the world in order to develop these specific dyes. And these specific dyes can be found especially in the life science. And you will see here some example of some dyes that we put in the liquid. And we have a very specific process in order to prepare and to manufacture all this liquid. And it's not just a question of putting this liquid inside. We have to prepare them, give a certain number of days in advance. And we also have to prepare the two liquids to live during decades and centuries together. So it's like a wedding. We prepare the two liquids in order to make sure that the two liquids accept them each other, and they merge well each other. For sure, they are UV resistant because they have to last decades, and that's why this is the best dyes that you can find in the world, and in order to provide with the very highest purity, a very long lasting. Then we have the tube of glass. So the tube of glass, when we have the raw material, is linear. You know, it's a linear tube that is used in the medical industry with the flow of blood, for example, inside. So this is the highest quality. And we had to develop special machines. We did a Tour du Monde, a world tour, in order to try to find somebody who was able to bend this tube of glass. And we didn't find. So we had to invent the machines in order to transform a glass which is linear into a circular one or a skull one. You will see also, and on this specific machine, you will see the production of this glass. This is accelerated time. We need approximately 20 minutes, something like that, in order to bend it really precisely. And you see that the bending is done, and for that you have to manage, we have multiple motors in order to move in different axes the capillary. And imagine that the tube of glass is inner diameter is 0.8 millimeter, and outside is 1.6. And when you heat it, you transform the glass into kind of liquid. But if you heat it too much, it becomes real liquid and everything is dead. And if you don't heat it enough, it breaks. So you have multiple parameters like speed, heat, etc., and force and correction, different axes in order to be able to bend this glass. Then you have optical effects. Inside the capillary, we have 0.8 millimeter. But if you look at, and here we have the watches, if you look at the visible diameter of the liquid, it looks like it's filling the entire external diameter. It's because we magnify it. It's like a magnification, like a loop that we have, thanks to the shape of the capillary. And although you have this small inner diameter, the visible diameter which will be much bigger. And it was very important for us in order to have a spectacular view, and the largest one, view of the liquid inside the tube of glass. We did, in order to also improve the visibility, we have done a world first, specific light system. We have patent on that. You know that there are some minute repeaters and some clocks that used to ring the hours a couple centuries ago. We wanted to provide a solution where you see in the dark or in the night the hours and the time, what time it is, but using contemporary innovation and science. And that's why we have developed this specific micro-generator, micro-system. It's a mechanical movement. There are 80 components, and it's combined together with a micro-generator. So how it works, it has a specific barrel spring. So you wind it up. You are the battery, because you provide the mechanical energy, and then there is a pusher. You push on the trigger, you liberate the barrel spring, and then you have a series of gears, and it transforms a rotation of approximately 3 rounds per minute up to 11,000 rounds per minute, which is a macro generator. And then there is this Faraday law that says if you have a copper wire, which is exposed to quick variation of magnetic field, then you create electricity. And this electricity is directly directed to 2 LEDs. And you push 1 time on the button, you have 4 seconds. If you keep your finger pushed on the button, it lasts 14 to 15 seconds. For sure, we did lots of tests to make sure that the magnetic field which is created here does not impact the regulating organ of the watch, but that, as it's completely opposite, we did test and it doesn't impact. And you know that micro-generator is creating alternative current, and the LEDs need direct current. So in order not to put electronics inside, we have no battery, no electronics, because we wanted to keep the whole GCOL spirit and innovation of HYT. Because of that, we have 2 LEDs, and when one receives the positive current, it's on, and the other is off. And then this is the contrary, because the two, and when the second one received the negative current, direct current, it's on and the other is off. So it's like a stroboscope. We did that in order not to put electronics, to transform, like a transformer. And the frequency is 1,200 hertz, so your eyes will not see, the small variations of the two LEDs. Then we go to position control. So for that, we need a very sharp and precise interface with the mechanical movement. We need a thermal compensation, a very tight, perfectly tight system and production process that are also allows to bring this very clear position of the liquids. So here, this is the vision of the interface with the mechanical movement. Here, we take the information of the hour's end, which is rotating, and we transform a rotation movement of the hand into a linear movement thanks to a cam, which is this component, which has a snail shape. And then we have this component, which is called the palper. And you will see in this animation that this cam make a turn in 12 hours. And at the beginning, it's in this position. And at the maximum position, it will be here. You will see the animation where we transform. So you see the beginning of the day is at the very beginning of the cam. Then the cam rotates. And with the rotation, it will compress this below. And then by compressing, you have the green liquid, which is flowing out. You see here at half of the stroke of the cam, it's noon. And at the end, you will see that it will jump. And by jumping, it gives a possibility of the two bellows, which are flexible, to come back to their initial position, because they're like springs. And by coming back to the position, the bellow from the left side sucks the green liquid back, and then you have this rewind movement. A watch which is waterproof is waterproof with some technologies that have been developed in order for human usage. That means that when you go to dive or when you take a shower, you don't stay 1 year under the water. The liquids that are inside the fluidic device, they have to stay inside for decades. And we have to make sure that in 50 years there will not be any leak, because if there is a leak, then you will have some problems of precision of the indication. That's why the technologies that we have developed and that we use today took their inspiration from atomic physics in order to make sure that it's completely sealed, for example. And we measure that with a helium leak test. And the level of tightness that we have for the fluidic device is 10,000 times more tight compared to a watch that follows the same test, which is called the diver watch. The technologies have nothing to compare, and it's very important because otherwise you have the sensibility of the time, the precision issue, and then you can have some pressure, with pressure variation, you can have some impact on the fluidic device. But thanks to this really high level of tightness, we control and we are sure that the watch will work perfectly over a long period. Then you know that all the liquids, they interact very, very importantly with the temperature. All the liquids on Earth. So if you heat a liquid, then it expands. And if you cold them, it compresses. This is the base of the technology of the thermometer. Thermometer, what is it? It used to be mercury before, now it's digital, once again. But there are some still with alcohol, and when you hit it, you see that the liquid flows inside the capillary. So it's expanding. And here we have a kind of thermometer. That means that we have a liquid inside, and the two liquids expand. The transparent liquid, when it expands, goes into this chamber, but this one, which is compressed by the mechanical movement, cannot expand. So if we don't have a solution for the thermal compensator, you will see this on this small video, this one will not move, and you will have this liquid, green liquid, that will move forward. And the sensitivity is very high, because every time you increase by 10 degrees Celsius, then the green liquid will move by 30 minutes of indication. So it's very important, because when you wear the watch and then you put it on your table, the variation of temperature is 10 degrees approximately. The body is 32 and this one is 20. So you will see up, it will move, I stop it, but it will move here. This one will go up and this one will not move. And you see here if you increase the temperature. So we had to invent, we have patents also on it, what we call a thermal compensator. It went very quickly. So here it's a view, a 2D view inside the bellow. And you see that inside the bellow, you have the green liquid which take all this volume. And otherwise, we have a part which is here that allows to have a small component. We have a close-up just after, a small component which is called a thermal compensator, which is here to compensate the temperature variation that impacts the system. And this thermal compensator is a very tiny bellow, the same as this one, but very small, and inside there is a liquid. And this liquid is specific. It's a specific development. So inside HYT watch, we have 3 liquids, not 2. This one is hidden and you don't see it. And the aim is that this small component expands, because there is a liquid inside, so it expands. And by expanding, it's attached to the top of the big bellow, and thanks to the expansion, it will pull the big bellow up, and if you pull the big bellow up, you give an additional volume. And this additional volume, in a very, very precise way, corresponds to the expansion of the green liquid. You see it? So here, this is the thermal compensator inside. You see that it's a bellow. It's attached at the top, and this is fixed because this, at the bottom, is given by the pressure of the mechanical movement. And you see that when you hit the system, you see the expansion. You know, this one is expanding, and by the expansion of this one, it pulls up this big bellow. And if you pull it, you give more space, more volume to the green liquid. And instead of the green liquid to flow forward inside the capillary, it will not move, and the expansion will be completely inside this bellow. We have one patent on it, and thanks to that, you have a watch that can work at 10 degrees, 50 degrees, and all this management of the variation, temperature variation is managed thanks to this component. Then you have the process. You know that when you have the fluidic device, it's full of air. And then we have to take out all the air and to inject the two liquids. But it's very challenging because the fluidic device is completely tight. So we had to develop special machines and we had to develop special process. We had to train people for somebody to be able to extract the air and to inject the air to create the meniscus inside the capillary. You need 12 months of training. And for us, the training of the people, education, I come back to the education, is a key element of the culture of HYT. So you will see on this video that there will be, you will see extraction of bubbles, and you will see some bubbles that will be extracted inside, you see here. So in order to make this extraction, injection of liquid, extraction, and then the contact point of the two liquids, we had to develop these special machines. We have one example of machines that is exhibited here, and inside the HYT and Preciflex team, we need not only engineers, PhDs in order to invent the thermal compensator and all that, but we need also people to create the machines in order to be able to produce. So it's a whole project, it's a very holistic project, and we cannot just develop a solution without thinking on how we will produce it. Now we have most advanced machines like vacuum priming, which is making the same job automatically. And you see with this very nice video that there are a lot of flow of liquid. And here, because we created the vacuum inside, then the two liquids here enter into a contact very easily. And the extraction of the bubbles is done. And why don't we want to have bubbles? Because you know that bubbles of air, they interact with the pressure. You know, this is not thermometer as we saw before, but this is barometer. And when you take the plane, you know, you go to pressurized cabin, but it's like you are at almost 3,000 meters. And at 3,000 meters, the pressure is going down. And you have a law of gas saying that if you have a decrease of the pressure, then for a given volume of gas, the gas will expand. So the small bubble, if you go up to the mountains or into plane, if you still have small bubbles inside the fluidic device, the small bubbles will become big. They will take more place, and they will push the liquid, and then the indication of the time will not be precise and will be impacted by the pressure variation. Then we have to calibrate, to do the calibration. This is here on this machine where we set the position of the noon to give the possibility then to watchmakers to adapt this fluidic device with the mechanical movement. And to do that, we need to extract and to set very precisely. And you see here on this cotton that we extract very, very tiny quantities of liquids in order to give the setting of the noon. I will finish with the flow control. So flow control, now you saw some things which are static. Now we have to make all the liquid move on a very perfect way. And to do that, we need to have a special coating, this bellow system, which is unique, and then the fluidic resistance. First of all, the two liquids, they are non-miscible. The first video that you saw the production and the manufacturing of the colored liquid. Here you see that when you mix the two liquids, this is a transparent liquid, and inside this transparent liquid we put some droplets. We have put some droplets of the colored liquid. And you see that the two liquids do not mix, and but they need to know each other with time. So we have a specific process when we create the two liquids. Before injecting the two liquids inside the fluidic device, we have this specific process in order to create this combination of the two liquids. Then maybe you drink some wine. I hope for you, French wine, I recommend. Swiss wine is okay also. If you take some red wine, you know, generally you rotate your glass. Why do you do that? It's because there is a specific, and all the liquids love the glass. So that means that the liquids, they stick and the wine is sticking on the glass. And this is how you deduct, according to the legs, you know, some property of the wine. We have liquid and we have glass. So in order to avoid the liquids to stick to the glass, and for example, to have lots of dots of colored liquid inside the capillary, we had to develop a special and unique coating with our American friends. So thank you very much for having given us the possibility to develop that. This special coating, the aim of this special coating is to repel the two liquids. And what is tricky is that you have two liquids that have opposite properties that repel each other, and we have to have one which repels the two liquids that repel each other. And this is done. You see here the colored liquid, which is which falls on the glass with no specific surface treatment. And here you see it falling on the coating. And all this angle, which is called the contact angle, is precisely managed for the two liquids. And all that is very, very high tech. The coating is transparent. It's applied inside the tube of glass, all along the tube of glass of 0.8 millimeter. It's transparent, otherwise you would not see the liquid. And this is, apart from the movement, the most expensive component of the watch. So it's, for us, it's a very key and strategic component. And it's really unique. Then the bellows. These bellows are flexible. It's really kind of signature. It's a balance. There are 25 microns of thickness of the wall. It's a balance between the minimum energy that you need to compress it and the function of the tightness that has to be provided. That means that we cannot go on a very, very small thickness, otherwise there is risk that the liquids flow out of the bellows. But then in order to minimize the energy provided by the mechanical movement, we have defined and we have done this specific engineered bellow that is used today in aerospace industry. Then this is the fluidic resistance. This is how we control the speed of the flow inside the watch. You know that if a flow of liquid or gas goes too quickly, you create turbulence. And then there is a risk that the liquids mix all together. So in order to avoid that, we have to control the speed. And to control the speed, it's exactly like your bath tube. At the beginning of the presentation, you manage it thanks to the diameter of a hole. And this component, it's done out of ceramic, and the liquid flows during the retrograde. It flows from the capillary. Here it flows. It has to go through this very small hole, which is 52 microns, half of a hair, approximately. And thanks to that, you control the speed of the rewind. If instead of 52 micron, it's 56 micron, instead of 1 minute, it would have been 45 seconds. So there is a very important sensitivity between the diameter and the speed of the system. Then, to finish, we have to assure that we have stability over the time. That's why we had to develop special protocols in order to test all a new fluidic device that we invent, that we create. You know that we do not have 300 years of history behind us and a very big dictionary of the watchmaking, how to build a mechanical movement, the tourbillon, etc. We don't have this book. We are writing it, basically, the microfluidic books applied to the watchmaking industry. But so that's why we had to create protocols that test over a long period all the fluidic device when we develop a new one. So you see here that we do, I would say, standard test of back and forth, like a mechanical stress. We do thousands and thousands of tests. But to assure that you have the chemistry inside which will resist with the years, it's not by compressing it that you will make sure that it will resist. So that's why we apply a chemical aging. We increase the temperature of the system. We go up to 70 degrees Celsius. And there is a chemical law saying that you accelerate the time by 2 if you increase by 10 degrees Celsius. And 1 year is equivalent of 1 month in a special oven at 70 degrees. That's why we are sure that in 40 years, because we did tests during more than 40 months, in 40 years, the fluidic device will work and the dyes will have the same color of that. But we had to go above and to develop also these specific protocols. All that generated intellectual property for sure. We have 8 patent families and more than 20 patents pending in all different countries. And you have the watches here. Charles is here also to present and to answer to all your questions. You have the H0 model that is shown here. We have developed this collection in order to show in a very spectacular way the 3-dimensional indication of the time. So here you can see from the sides the flow of the time. We have hidden the mechanical movement on this one because we wanted to catch the focus of your eyes on the liquids. We wanted to, it's a watch which is dedicated, it's a tribute to the liquid, to the fluid time. We just have won 3 weeks ago the Red Dot Design Award 2018 for this watch. We have won the Grand Prix de l'Horlogerie de Genève in 2012 in the innovation category. And it's a very important recognition for our work. We have also the H3, which is a linear indication of the time. It combines mechanical movement together with a fluidic device. We have 6 hours that are displayed. That means that every 6 hours you have a rotation of these cubes that allows the visibility of the 6 hours after. And we have a complete integration between the two worlds, between the mechanical movement and the fluidic device, because in order to generate the rotation of the movement, we reuse the energy of the bellows when it comes back to its position. You know, we compress them and then it comes back. When it comes back, it has a force. This energy, we recycle it in order to actuate this cube. We have the skull. The skull model is an iconic product for HYT because it represents the essence of the fluid time. You don't have any indication of the minutes on this watch, so you will read the hours approximately, plus minus 5 or 10 minutes. So don't take this watch if you go to a very important appointment or if you have to catch a train or there is a risk to be late. Why it is important for HYT? Because the skull is the symbol of the memento mori. This is a memento mori, the carpe diem. That means that when you see a skull, it was used in ancient times, also in the Enlightenment period. When you see the skull, it reminds you that we will die one day, for sure, but it's not a morbid symbol. This is a symbol of life, because it reminds you that you have to enjoy the now, the present, and not tomorrow. So enjoy, spend the time. Don't be too much under pressure, because here you have all the information to be under pressure, you know. Here you know approximately where you are during the day. And what is also important is that we have bent the capillary in order to follow the shape of the skull. That means that the hours and the indication of the time, of the passage of time, follows the symbol of the passage of time itself. And that's why it's a very philosophical watch. It can be also a rock symbol, the skull. We did a special edition with Axl Rose, with Guns N' Roses. But this really integrates all the fluidic philosophy of HYT. I finish with the watch that we have presented at Geneva this year. It opens new perspectives on the time. You see that we have put here the indication of the hours on the side. So we did it like a sculpture. And the sculpture, you have to rotate, you have to turn around. You cannot just simplify it by taking a picture, a 2D. It's a 3D watch, and it opens for us new perspectives on the future of what we want to develop, on a certain vision, our vision of the horology, of the watchmaking industry. And this is what we will say as a conclusion. Time is fluid. I hope that you enjoyed the presentation tonight. You saw that we did a lot of work to invent and to reinvent devices, instruments that you wear on your wrist. It's written in the very long history of the combination of the fluids, the liquids, and the measurement of time. HYT is part of this very long history. And what we want to promote is that time is fluid, space is also fluid, and space-time becomes for sure fluid. And the time that we want to promote is a time that belongs to you. That is a human time. It's not an abstract time. And we like to say that time means nothing until you make it a moment to remember. So I will have a very important moment to remember tonight with this lecture. And thank you for your attention.
Any questions for Grégory? Raise your hand, I'll bring the mic to you.
First, I wanted to say magnificent. What a brave and exciting way you're going in horology. Question I have for you is you've shown tremendous amount of thought and detail about the temperature resistance and pressure resistance. How about magnetism? Are any of the components, such as the bellows, subject to magnetism? If left near a magnetic clasp on a laptop or something like that, can it be affected?
Sorry. The components of the fluidic device are not more than all the rest of the watch. So, these components are under big constraint. And you cannot, if the bellows had a very important sensitivity with magnetism, whatever, it will remain with this shape. So that means that it will not deform, contract, or whatever. So the indication will remain and will work correctly.
Grégory, I have a question for you. You explained the history very far back, thousands of years back. But what about the history in the short term? Where did this idea come from? Was there a discovery at some point where you or someone on your team said, "Aha, we can put fluids in a capillary and move them back and forth with mechanical watch movement"? Where did that come from?
So the idea, the initial idea, comes from a person, a physicist, who is called Lucien Vouillamot, who is one of the founder of HYT and Preciflex. And it was in 2002, 2002, there has been a national exhibition in Switzerland. And this national exhibition in Switzerland happened in Neuchâtel. This is where the company is located. This is the canton where La Chaux-de-Fonds also belongs to this canton. And the exhibition of the national exhibition was located in Neuchâtel, Bienne, where you have also Rolex, Swatch Group, etc., and another lake, which is called Mora. So this is called the region of the three lakes. Lakes, liquid, lakes, water. Neuchâtel, history, watchmaking, time. And Lucien had the idea to recombine these two universes. And having in mind all the history of the measurement of time thanks to liquid, clepsydras, watchmaking, water, clepsydra, etc., it brought to the idea to recombine these two elements where the watchmakers for centuries try to put the water out of the watch, otherwise it's not waterproof. So the idea and the concept was to reinvent and to bring something new. Then the first idea was not this watch. It was like linear indication. The design was really interesting to see. But then it is interactions between design creators, engineers. How do we do in order to keep the liquid very tight in the system, so the bellows system, all that. So that means that the aesthetic and the design is a result of technological constraint, invention, creativity, and then, for sure, a merge with real mechanical project, because there is not. Here, I wanted to explain and to draw really everything which has been done, the fluidic device, but we also have the combination of the watchmakers, the mechanical movement, which is done particularly for HYT, because it has this specific interface, specific design. So it's a combination of these two worlds that required all these years of development.
Thank you so much. That was so cool. Thanks for coming all this way. I guess what I'm curious about is, are you guys already at the smallest scale you can exist at in terms of the size of the bellows? Is there constraints in terms of microfluidic properties? Or do you see a more traditional, smaller case, something, because I love how striking it is, but in order to kind of enter more into kind of the mainstream, if you will, of the watch industry, do you see a more traditional approach that's possible?
Yes, I would say 2 times yes. So the first time is we are working in order to develop a watch which will be smaller in terms of diameter and also of thickness. And we prepare that for men and so also for women, but it will be in 2021. So it's long-term development. One of the big challenges to do that is not really the size of the bellows, because you saw that with the thermocompensator we can go really down up to the size of a rice grain. But the challenge is the movement, because you need, if you reduce the size of the bellows, then you cannot reduce the size of the walls, because otherwise you will have some tightness issues. So this you cannot change. And if you reduce the size of the bellows, but with the same size of the wall, your bellow will be more stiff, will be stiffer. And if it's stiffer, it will require more energy from the mechanical movement. And if it requires more energy from the mechanical movement, you need a bigger mechanical movement. So there is a contradiction to reduce the size of fluidic device and also combine with the mechanical movement. So that's why we have decided to develop a very watchmaker project in order to have an extra power, superpower movement in a limited volume. And this we do with very amazing partners, and that's why it will be available later. Then the second yes is it's more Preciflex, the sister company of HYT, which is working on the technology. We also work on really amazing projects because we have the vision that HYT is a Formula One of the fluidic urology. But we would like to do also and to have the possibility to propose the equivalent of the Swatch, what Swatch did, which is amazing project. And to have this possibility, for sure it will not cannibalize, it will not be the same technology. It's a technology which has nothing to do with this bellows, with whatever. It's completely new also. But the aim is to bring to life, and it's a huge project, not easy, but very exciting, but to bring to life like the fluidic Swatch one day. And as of today, it's between 2022, 2023. Thank you.
Any other questions? Yes, Erica.
I'm wondering, do you have this in a vacuum? The bubble I see, is that a vacuum inside?
So we use a vacuum in order to extract all the air out of the fluidic device.
Okay.
And when the air is completely out of the fluidic device, we have a special system where we inject the liquid.
Okay.
So that means that the injection of the liquid is done when the vacuum is done, is this special chamber, where the aim is to recreate the vacuum inside the fluidic device.
All right, that answers one question. But the bubble itself, the crystal, so to say, what I see from the outside, is there inside a vacuum? Is the movement sitting inside the vacuum space?
Of the watch?
Yeah.
No. Because once we have injected the liquid, we seal it. I would like to say for eternity, but eternity, I don't believe in it. But almost. So it's completely sealed, and when it's sealed, the liquid, it's completely tight, and then we can use, and you have one here, you have the fluidic device that can be assembled, with the mechanical movement, and here you have the watch, and there is no vacuum inside.
Well, the question comes because, let's say you're going in space, and the outside pressure is reduced.
Yeah.
What happens?
No effect. Why? It's because there is no air inside. No air, any single bubble of air inside the fluid.
No air in the liquid tube, in the tube where the liquid itself is. But there's also no air in that space that encapsulates the movement.
Yeah, so it's a watch, like all the watches, the dome of sapphire that you see. Okay. It's so that means that for sure, if you take your crown and you move it, there will be some exchange of pressure because it's not completely tight. It's like a normal watch. Yeah.
Thank you.
I was wondering, so the frequency for the fluid to move is 12 hours. Is that more a design decision or engineering decision as opposed to, say, 24 hours?
Good question. Thank you. Well, first of all, we have the H3, where we have 6 hours on the H3. Then, We have, and maybe it will come out one day, to have a 24 hours indication, not the 12 hours. But what we wanted to do is, there is a magic moment, two magic moments, especially in the day. These are the two rewind, where suddenly you see the flow of the liquid, which is going quickly, And this is where you see that, okay, the time is like stopped. It rewinds. And we wanted to have these moments not only once in a day, like at midnight you sleep, so you will never see it. So that's why it's a combination of, we wanted to create the emotion when we see this rewind movement, and we wanted to have it sufficiently into action. There was the idea of not putting the indication of the time to indicate the hours, but the minutes. And then you have, 60 times this movement. The problem of the 24, of the minutes is you need a lot of energy from the mechanical movement in order to compress 24 times a day. And as of today, also with the very extra power movement, we would need like a monster, like a triple stuff, etc., in order to be able to bring the energy to do that. So once again, it's a balance, it's a trade-off between what we wanted to show and the emotion which is behind that. And this rewind movement is very important for us because for sure you see the dynamic of the liquid, but when the green liquid goes back into the bellow, it goes through this very tiny hole, and then there's a vortex, there are turbulence. That means that when the green liquid comes back into the bellow, it's remixed completely. So that means that every time then the green liquid is flowing out, it's a new molecular configuration. Time is never twice the same. Your eyes don't see the molecular configuration. It's more the philosophy of it. But then you never swim, you never step twice in the same river, as Heraclitus said. Change. And here you have the visibility of also the change of this, because it's a unique configuration. Every time there is the liquid which flows out in the capillary.
The part where you said, I have like a couple questions, but you mentioned you have strobe lights, but no battery. So, and then you mentioned the copper. So how are you generating electricity in the watch without any battery? And then is it an automatic watch with the liquid? So like it generates with the hand movement, or is it mechanical? And then how do you change the minutes? Like if you have to change the time?
Yeah. So to answer to your second question, it's a manual winding mechanical watch. It's not automatic, it's a manual winding. Then to set the time, it's like on all the watches. You have the crown, you set, and you see the movement of the hands, and then the movement, instead of moving our hand, you will see the liquids that flows. And so it's a normal setting and a normal use of a mechanical manual winding. To your first question concerning the generation of electricity, so for sure we have no battery, no electronics. And to do that, we use a law that has been invented by a British physicist in the 17th century, which is called Faraday. And this is electromagnetism, so that means that he found out that if you take copper, a wire of copper, and you apply just beside it a variation, very quick variation of magnetic field, then you create a flow of electrons, you create electricity inside the copper. And what we did is we did this micro generator, which is 4 millimeter diameter. And we have a wire copper, which is in the center. Then we have the magnets inverted. We do a rotation very, very quick of the magnet. So that means that you create variation of the magnetic field. 11,000 rounds per minute, it rotates like a Ferrari motor. And then thanks to that, you create the electricity within the copper. And then the cable, you go and you linked it to LEDs. And then you have this creation of electricity, which is used in order to bring light inside the watch.
I think we have time for one more question, and it's all the way in the back.
Do you foresee adding a date feature?
It is, sorry?
A date, adding other complications or a date feature to the watch?
Also a good question. We have lots of discussion inside the company. So the essence of HYT is to have created a special device in order to show in a different way the time. Then we had a lot of questions. Will we integrate a chrono, a date, a tourbillon, a moon phase, or whatever? The thing is that I think that HYT has something else to bring. And if we develop a complication, I would prefer that one day we will bring a fluidic complication, maybe a fluidic date, I don't know. But, to integrate, I would say, standard mechanical complications that you find on the other 200 or 300 Swiss brands that exist, for us it doesn't make a lot of sense. But we are here to try to continue to shake our neurons and to find maybe new complications in the future.
Thank you.
Thank you.
Let's give Grégory another hand.
Thank you. Thank you, everybody.
Yep. All right, thank you, everyone. Let's see if I can get this up. It's okay. It's no big deal. So the next meeting is September 10th. We're on summer break. July and August, we'll take off from our monthly lecture series. But our horological education classes upstairs and our traveling education classes will go on. So we will see everyone back here on September 10th. And thank you, everyone. Have a great night.